Welcome to the third video of the fifth chapter of the Crystal Clear Electronics videos. Our presenter is still Mr. Danyi, who has already told you a lot about measuring voltage with multimeters. What can we hear about in this video?
In this video, we'll talk about current measurement. This is a particularly important chapter in this topic because incorrect wiring, incorrect use of the multimeter, or incorrect selection of the measuring range can easily destroy the connection or the measuring instrument. But I don't want to scare anyone. This video is also made to help you avoid them. If you want to measure current, then the multimeter is always connected in series to the circuit because we want to measure the current flowing through the device. Wiring in this way makes the measurement difficult since the circuit must be opened at the point to be measured. There is also a serious threat in case of this measurement. In order that the connected instrument does not affect the measurement, it was designed so that its resistance is very small, which means the risk that if we set up our measuring instrument for the current measurement and accidentally connect it between points where high current, for example the output of our power supply unit, can be flowing, that can also damage both the circuit and the measuring instrument. Pay attention to this during the measurement. When measuring current, the current direction is positive if it flows into the red wire and the black out. Then you see a positive number on the display. The current direction is negative if it flows in the other direction. Choosing the right measurement range for this measurement is not a task without danger. In this case, the measuring instrument has a small resistor value, which is different in case of different measuring ranges and insignificant from the point of view of the circuit. The value of the resistor used to measure smaller currents is higher, which means that the higher the current flows, the hotter the resistor gets or even burns out. With this phenomenon, we will learn more about load capacity of resistors at the end of the curriculum. Therefore, the correct selection of measuring limit has a great importance. If we are uncertain about the amount of electrical current to be measured, it's worthwhile to try a larger measurement first. In order not to break the measuring instrument so easily, a fuse is built into it. If I would measure a current higher than this value, my fuse insert would unlock, which would protect the rest of the instrument, but unfortunately, I would have to replace the fuse insert.
In the first video, you mentioned that your multimeter has a 10 amps limit. Based on what you have said so far, it's unnecessary. Or is it not?
You listened very carefully. I did say that, I didn't lie, and there is no misspelling on the instrument. It is possible to measure higher currents, but this requires extra care. I have already mentioned that there are also multimeters where the measuring cables are fixed to the case, which means that unfortunately, we cannot choose how to connect the measuring cables to our multimeter. For such devices, be sure to read the instructions before use and what nominal current is allowed. Here is a summary of what is happening in the measurement of the different currents for the two different wiring modes, fused and unfused. I'd like to note here that I'm trying to interpret this table in relation to the multimeter in the written textbook. If you look at the top row, you will see that there is a separate column for notes on fused wiring. On the right side there are notes on unfused wiring, and on the left side you will see the relating currents. If we look at them in order, we can see that if we want to measure between 0 and 200 milliamps, the fused connection mode is the recommended one, so the instrument measures correctly, if the measuring limit is correctly set with the rotary dial. In comparison, the unfused wiring mode is a bit inaccurate over this current range and is not usually recommended. The instrument measures correctly if the measuring limit is correctly set with the rotary dial, but we prefer to recommend the fused connection. If you go further and want to measure between 200 milliamps and 10 amps, you should avoid the fused connection method because the instrument has a fuse to protect it from further damage. And in such cases, the fuse insert will need to be replaced. Instead, we recommend the unfused wiring method. The instrument will measure correctly if the measuring limit is correctly set with the rotary dial. But you have to pay attention to the time of the measurement. The instrument can overheat as mentioned before. Finally, if you want to measure currents greater than 10 amps, fused wiring should be avoided for similar reasons to the previous one. The fuse in the instrument is solved to protect it from further damage. The fuse insert should be replaced. Attempting to use unfused wiring at such high currents is a serious hazard because the instrument will be overloaded and can be destroyed at any moment.
And what happens if we have to measure a voltage higher than 10 amps?
We have the opportunity to do this. One way is to connect a measuring resistor to the system and measure the voltage across it. And using Ohm's law, we can easily calculate the current flowing through it. The other option is to use some other measuring device, such as the padlock clamp mentioned earlier. With this, you can go high up to 1 kiloampere.
Thank you.
Before starting the measurement, we must definitely estimate the current to be measured. Often there is a resistor connected in series in the branch to be measured. If we know the value of the resistance, we can deduce the current from the relatively easily measurable voltage on it.
Ez lehet például még egy másik módszer az előbbi problémánkra.
If there is no possibility for such a measurement or estimation, please refer to the datasheet of the given device. If we cannot finally estimate the current, then choose the 10 amp measurement limit with the corresponding wiring, and then reduce it if possible, as we previously learned from the voltage measurement. Now let's look at a specific measurement here. Gergő, I'll ask for your help again on this. Prepare our previous connection used at voltage measurement, which consisted of two resistors, 100 ohm and 1 kilo ohm. We have already measured the power source there. Now let's see what the current in this circuit tells us.
Mit mond ebben az áramkörben?
We get a value of around 11 milliamps, and I'll also show the reverse connection here. In this case, the measured value is minus 11 milliamps.
If we had done the estimation beforehand, based on the resistors and Ohm's law, we could have estimated that we would expect a value of around 11 milliamperes. This is important for the mentioned instrument because there we have to manually set the correct measurement limit. Fortunately, our multimeter does this for us, so Gergő didn't have to pay attention to this. But in your case, it is important, so it is always worth estimating the strength of the current flow by calculation. If you like, you can make sure that you measure the same current in the branch everywhere. Here I would also make a small summary. Current measurement should only be performed with due care, because both the circuit and the multimeter can be destroyed. If there is a known valued resistor in the branch to be measured, it may be appropriate to trace back the measurement to voltage measurement, as we have done in case of the estimation. If the value of a resistor or the voltage on it is known, then the current flowing through it can be calculated. If the previous is not possible, follow these steps. First, estimate the quantity to be measured, select the measurement limit, connect the measuring cables to the multimeter accordingly. Second, turn off the circuit. Third, disconnect the circuit at the measured point and connect the multimeter in series. Fourth, perform the measurement. If you measure a current greater than 200 milliamperes, be careful not to overheat the instrument. For example, for large currents, we take a minimum break of 15 minutes for a maximum measurement of 10 seconds. Fifth, when the measurement is complete, turn off the circuit and restore its original state.
Thank you, Béla, for the detailed guidance. I think the summary table of the wiring methods and the many tips to protect both the circuit and the instrument from damage will be very helpful to the viewers of this video. We look forward to welcome you back in the next video, where you will hear about resistance measurement and continuity testing.
Bye bye!